All right, welcome back to acid and base. So let's talk about weak acids and weak bases. So the difference between strong acids and weak acids is that strong acids will fully dissociate in water, which means that when you have a strong acid and you put it in solution, it's going to break up into its constituent ions. And what that means is if you have hydrochloric acid, which is HCl, when you put that into water, it's going to break up into hydrogen and chloride. Okay, so you're going to have a hydronium and a chloride ion. Well, weak acids and weak bases don't fully dissociate. So right here we've got a reaction for a weak base. This is a generic base we're going to call Z. Okay, we're going to add it to water and it's going to give us Hc plus OH minus, but it is not going to fully dissociate. So our Kb, okay, and remember K is our equilibrium constant for the base, is going to be a little bit different. It looks very, very similar, but we have to account for the portion of our concentration that is not fully dissociated, all right? Such as where we have the x squared over F minus x. So remember, F is our formal concentration. Okay, and then if we look at the next part that I've got written up here, alpha, this is the fraction of association for bases, is going to be BH plus BH, or divided by BH plus B. Okay, so this is the conjugate base divided by the conjugate base plus the concentration of your base is equal to X over F. Now, if we take what we know now about weak bases and their conjugates, and we take this problem down here, 0.08 molar solution of base C has a pH of 10.98. What is alpha? So now let's look at our alpha formula again, okay? We've got the concentration of BH over the concentration of BH plus B. We don't have hydronium or hydroxide in this, but we know, thanks to our Kb formula here, that X, we're using the same X that is equal to BH plus is also equal to OH minus. So now we know that that's our hydroxide concentration. Well, we don't have our hydroxide concentration. We have a pH. Well, we can take our pH and we can get our POH. All right. So our POH is going to be 14 minus our pH, and then we can say that our POH is negative log of the concentration of our hydroxide, right? Which is going to be equal to this guy. And we can use our pH, our POH, which we can figure out from our pH, to find our alpha. I'm going to write up some numbers up here and we're going to see what we got. All right, so I filled in a few numbers here. We've got 14 minus our pH, okay, and then our pH is 10.98, so that's going to give us 302. Now remember, this is our POH. Okay, so in order to find our concentration of our OH, we got to reverse this and remember that the concentration of our hydroxide ion here is 10 raised to negative POH. Okay, so that's going to be our hydroxide ion concentration. We're going to put that over top of our concentration here, and that's going to give us our alpha value as 1.10 times 10 to the negative 2.